Number 19, page 439. This example of the law of sines is going to show when we have the ambiguous case and we have to worry about having two triangles. So let's start by drawing a triangle and filling in what we have. So here's our triangle ABC. We don't know if the angles are acute. The missing ones are acute or obtuse. So ABC. And I know that angle A is 64 degrees. Given that side A is 16 and side B is 17. So then you can see we have the ambiguous case side-side angle. So what we're going to do is we are going to find an angle and then from there see where it leads us. So I'm going to find angle, I put the sides on the wrong side. Sorry about that. This is side B is 17, not side C. So the 17 goes there. Okay. So since I have angle A and side B, I can find angle B. So I'm going to do my law of sines, and I'm going to do sine of angle A over side A equals sine of angle B over side B. Filling everything in, I can solve for side B, first angle B. So sine of 64 over 16 is going to equal sine of B over 17. So sine of B is going to be 17 times sine of 64 over 16. This is sine of B. So that means that B is going to be the inverse sine of this fraction. That's our B. Okay? And we're going to find that B is going to equal 73 degrees. Now, we don't know how long side C is, so that will determine how big angle B is going to be. So this is just one scenario. So we're going to call that B1. Then we're going to find the rest of the triangle. So now we'll label our triangle as C1 and B1 here. And then we'll finish solving it. And then for C1, and then we will move on. So it's easy to find the angle now. So angle C1 is just going to be 180 minus the two angles we already know, which are 64 degrees. And we just found that angle B1 is 73 degrees. So angle C1 is going to equal 43 degrees. So using that, we can now find the measure of side C1. So we're going to use the same relationship with A. So sine of 64 over 16 is going to be sine of our new C, which is 43 degrees. And that's going to be divided by little c1. Now cross multiplying and simplifying, we're going to put in our calculator 16 times 16 times the sine of 43 degrees divided by sine of 64 degrees. And when you put that in the calculator, you get that C1 is 12.14. Now the problem is, as we said, we didn't know originally how long C was, so that's one possibility. Another possibility could be that B could be an obtuse angle. So B, instead of 73, could be, so we'll call it B2, could be the obtuse or the supplement of that angle, which is 107 degrees. Okay? So what we want to do then is find a new C, angle C. So we'll call it C2. C2 is going to equal 180 minus our 107 this time, minus our 64. A was given, so that doesn't change. So angle C might just be a real tiny little 9 degrees. So then we have to find a new side for that. So then we're going to use our relationship with A, because that is definitely known and given. So sine of 64 over 16 is going to equal sine of our new angle C, which is 9 degrees, divided by C2. So rearranging and solving, we get that, C2 is going to equal 16 sine of 9 degrees divided by sine of 64 degrees. So C2 equals 2.78. So if we were to draw a triangle for that, what we would have is this. Here's our 17, and now we're going to have a real tiny angle here. And then here is our side C. So here's A, B, 2, and C2. So here's our 9 degrees. Here's our 64 degrees. This is our 107 degrees. Here's our 17, our 16, and now this side is just 2.78. So there we have the ambiguous case with two triangles.